It is 4:20. You guys all made it here, so that's good. I wasn't sure. I kept kind of waiting, as you guys probably were too, to see are they going to cancel and shut it down or not.
I was hoping they were
So
not.
you guys are in the class after this. Did they cancel their class? No. Okay. So you have to be here anyway. So okay. I apologize. I printed out the notes and at my house, and I was going to make copies of them when I got here, and I left them at my house. So fortunately, I mean, you already have the notes for this 2-5 because I gave those to you last week. But the notes for the next section, we're covering 2 sections tonight. The notes for that section, you'll have to just write down, and I'll try and talk about them. But it's nothing. It's not like pictures or anything like that. So it's just It's just like equations and expressions. So it should be pretty easy to copy down on a piece of paper. But I apologize. I had planned to do that, and then I had it all printed out, and I had it sitting there, and I was like, oh, I got to get going, and I left it sitting in my room. So, okay, so here's our schedule, and I'll hand back tests maybe after this section. But here's our schedule for, and it's on the syllabus too, if you look at the updated one on Moodle. But this week we're covering section 2-5, which is the end of chapter 2. It's weird because of having to push the test back, but that's the end of chapter 2. So actually next week we will have our test on chapter 2, which will be section 2-1, 2-2, 2-3, and then 2-4, which we did last week, and 2-5, which we're doing tonight. So we'll have our test for chapter 2 next week, and just like last time when we had our test, I will try and be here as early as I can after school and answer questions until about 4:40 if people have questions, and then I'll let you take your test, and then we'll do a section after that, and then you'll get to, again, hopefully leave fairly early, depending on how long everything takes. Tonight we're covering 2-5, which is, like I say, the end of chapter 2, and then we are going to do a review section. Maybe some of you will remember how to do these things, and some of you won't, but it's a review of factoring. And so factoring is going to kind of come into play in chapter 2 as we move on with chapter 2. So I want to make sure that we have reviewed or learned that, because it's maybe been a while for some of you guys since you did factoring. So that's what's on the docket for tonight. This first one is actually fairly short. The second one is a little bit longer, just because we do kind of all sorts of different examples of factoring to review. So I actually got up this morning and made videos because I was like, we're probably not going to go. And yeah, so anyway, but so the videos that I make tonight won't be the live one, unless somebody really wants to see that, but it'll be one that I made this morning for that. So anyway, any questions on that? Does that make sense? I suppose I should check to see who's here before I get going. All right, so let me see. Ed there is okay, and Michael Canales, okay. We all have our masks on. I can't tell who anybody is anyway. Concha, you're right here in the front. So, Vanessa, is she here? Somebody emailed me, and I can't remember who it was, but said they were going to be gone. It might be Vanessa. Ariana, okay, or Ariana probably. Jamerson, okay, and Samantha there, and Sally is not here. And
Sarah's not here.
she emailed me, but anyway, Ana Mejia or Anna, she just stepped out, and Fernanda, okay, and Jose, Andrea, okay, and Carlos is back there in the corner, and Antonio. Okay, and Logan is back there, and Renee's right there, and Blanca right there. All right. So yeah, it must have been her because that's the one that I would have remembered. Okay, so we're going to talk about absolute value functions tonight, and we're gonna do a little bit with some equations and inequalities at the end. But at the beginning, we're going to talk about the graphs. And so if you remember, absolute value functions were one of our toolkit functions. And so here, to remind us what they look like, anybody remember what they look like before I draw it?
Go right ahead.
I'll go right ahead. Here we go.
Like a V?
Yes, it's a V shape. I'm going to use these markers. I think they'll show us a little bit better. But it's a V shape. It's what we call the vertex is right here, and it goes up like this on this side, and it goes up like this on this side. Okay, so if you may hopefully remember seeing that, we may have even had that on the chapter 1 test as, you know, moving some of the stuff around there. I can't remember. Do we have one of those on there?
I think so.
Okay. Seems like we did, but you know, I forget things. So the reason that it's talked about again in this linear function chapter is because actually, there she is. Because actually, absolute value functions are a piecewise function, which means you take one piece and another piece and you put them together. And if you look at it, here's the two pieces. The left-hand side is a line with a slope of -1, going down 1 over 1, down 1 over 1. And then the right-hand side is another line with a slope of +1, and they both have intercepts of 0. So it's actually a piecewise, and we don't have to really think about it, but it's actually a piecewise function. So that's why we cover it in this section, is because it's two lines put together to make that V shape. That's nothing you have to memorize, but that's what that absolute value function is from. I didn't have time to test it. Okay, yes, it's working. So you will want to write this down, and it's probably on your notes already if you have your notes from last week. But the absolute value function is commonly used to determine the distance between two numbers on a number line. And the reason is, if you remember, absolute value can never be negative, because the absolute value of something is always going to be a positive number or 0. So what we do, if we want to find the distance between these two numbers, A and B, on the number line, we take the absolute value, and absolute value is just those lines, absolute value of B minus A. So we just subtract and find the difference between them, and then that might be a positive or it might be a negative, depending on what order you put them in. And then you take the absolute value, and that makes it automatically the distance between the 2 points. Okay, so just as an example to see this, on a number line, if you had, let's say, -3 and 18, and we, for some reason, wanted to know the distance between the two, we do the absolute value of, and we can do 18 minus the -3, or we could do -3 minus the 18. And since we have the absolute value, it doesn't matter what order we put them in, we'll still get the same answer. So if you look at this one, remember what happens when we subtract the negative? It turns into positive. So this is absolute value of 21. And then the absolute value of 21, if you remember, is just 21. As a reminder, and we'll talk about this later, absolute value means distance from 0. So positive 21 is just 21 units to the right of 0. Okay. If we look at this one, this would be a -3 and a -18 is -21. And the absolute value of that is also 21, because it's just 21 units to the left of 0. Okay. So what that tells us is, again, it doesn't matter what order you think about this, but the distance between -3 and +18 is 21 units. So that's one use of absolute value, and I think we're going to talk about that in our next example. So let's take a look. All right. The example says, describe all the values x within a distance of 4 units from the number 5. Okay. So notice we've got 3 different things we're working with. We've got an x, we've got a distance of 4, and we've got a number 5. So we're talking about, it says a distance of 4, right? So that gives us our clue that we're talking about the absolute value of something. Now, what are we finding the distance between? And that's where you have to be a little bit careful how you read this. What are we finding the distance between?
4.
Yeah, a couple of people got it. It is the distance between x and 5. Okay? X is what numbers are we working with? And then we're finding the distance from the number 5. Does that make sense? It's the distance from the number 5. So x minus 5, or you can put 5 minus x, but it usually looks nicer if you put x minus 5, goes in your absolute values. And when we say within a distance of 4, do we understand that's an inequality? What does that mean if you say within a certain distance? And you think about like less than, greater than stuff.
within is equal to.
No, not within. So let's say, let me think if I can think of an example. We're going to talk about this again later. But within means, if I say, what's a good example without giving away my other example for later on? So, okay. So let's say that I have a number that I'm thinking of, and let's say that Elizabeth guesses that it's 20. And I say, well, it's not 20, but you're within 3 of the number that I'm thinking of.
Mhm.
Does that make sense? So that means she's maybe 3 units away one way or the other. She could be, it might be higher than her number or lower her number, but it's within. So it's like inside, or the distance is less than 3 from what my number is. Does that make sense? So that's the sign we have to use. If it's within a distance of 4, we have to say it's less than 4. So you're saying x's distance from 5 is less than 4 units away. That's what these words up here are describing. And this is how we would describe it with an inequality. Okay, now before I push this button, I have to warn you, I have a typo on my answer. So just ignore the little equal sign underneath it. It should just be less than. I realized that this morning when I was going through it, and I forgot to change it because I didn't think we were going to be here. So, whatever. Okay?
So,
Yes.
what about -5?
What about -5?
Yeah, I just want to know why it is become negative.
Why is it minus? It's minus just because that's the formula. It's not really a -5. It's just the first thing minus the second thing. So here's like the x, and here's like the 5, so it's just x minus 5. It's just in the formula of how we find distance. You subtract the 2. And we could have, and like I mentioned, we could have put the 5 first and the x second. It just looks a little nicer if the x is first. Okay, so that's how we would write that one. And again, ignore my little or equal sign there. Let's try this one. This one's a lot of words. Okay, so it says a 2020 poll reported, is this on your paper?
Mhm.
Yes, okay, so you can even read it from there. But it reported that 63% of Americans believe that the state of Montana should not ban students from using taxpayer-subsidized scholarships to attend religious schools, with a reported margin of error of 2.2%. The margin of error tells how far off the actual value could be from the survey value. And then we're supposed to express that set of possible values using absolute values. So this is what the survey value was. Okay, so you understand what a survey is? They ask a few people, and then they say, okay, if this maybe applies to everyone, but not exactly necessarily. So then they have this margin of error that says we could be off a little bit one way or the other. Okay, so from the people they talked to, 63% made this statement, whatever it was, I don't remember, but something about scholarships. Okay, so 63 is our point that we're looking at, right? The actual value, since the margin of error is 2.2%, the actual value has to be pretty close to that, right? It could be 63 plus a little bit or 63 minus a little bit. Does that make sense? Okay, so, but thinking about distance again, we would say, we could use whatever letter. I'm just going to use x again. X minus, what are we trying to find the distance from? Because the survey said, and I need to go back to it. So here's the important words. How far off the actual value is from the survey value. So the actual value we're using as x, and the survey value is 63. So we're trying to say the distance between those two is going to be small, right? So the distance between these two is going to be what if our margin of error is 2.2? I mean, what would we say after this? I hope not. We don't want it to be greater than, because that means the actual value is really, really far off from our survey. So we want it to be less than the 2.2. And let's see. That one might be a less than or equal to. Okay. And then if we think about that, we'll come back to that later, like how we would solve that. But that means it might be up to 2.2% higher than the 63, or it might be 2.2% lower than the 63. That's what this is saying as an inequality. Okay.
In that formula, you're always going to have a less than instead of a greater.
Not always. Sometimes we'll have greater than, but in this case, the first one was less than because it said within, so that means like closer to or smaller than. And then this one, the reason this one was a less than is because they're talking about a margin of error, and a margin of error means that you've got some value. Let's say let's say you're cutting something, cutting a board, and you wanted the board to be, let's say you work at a store and they say the boards are 8 feet long. But they're not probably exactly 8 feet long. They might be just a little bit longer or just a little bit shorter. So we would say 8 feet, but the margin of error might be like a half an inch or a full inch one way or the other. And so we want it needs to be less than that 1 inch or half an inch.
It can
So-
be greater than.
It could,
If you think like that, it can be greater than that.
okay, now you have to be careful. The absolute value is less than. Now the board, yes, could be bigger than 8 feet, or the board could be smaller than 8 feet. But what we're saying is the distance between the 8 feet and the actual length of the board is less than an inch or whatever. Okay, so you're right. You have this point, and the board is supposed to be exactly this long, but it's maybe acceptable if it's just a little bit longer or just a little bit shorter. Okay, and then this distance each way is like this number right here. We don't want it to be more than that much longer or more than this much shorter. That wouldn't be okay. But as long as it's small, a small distance either way, then we're okay. Does that make sense? So that's margin of error. And yes, it is possible that the actual distance is a little bit bigger than this 63, or the actual percentage, or a little bit smaller. Okay, but what we're talking about is this piece right here, which means distance. And again, that's going back to, if you look back in your notes, the distance formula. Distance from A to B is absolute value of B minus A. Okay, but yes, as far as in general, you can have times where it is a greater than. It's not always just automatically less than. And we'll get to some of those too. And we'll actually figure out how to solve them. So we're not just going to leave them like this. We're actually going to solve them. All right, so we've got our, I guess I used P for, I don't know what that stands for, population or percentage maybe. Yeah, sure. You're grown up, you can do what you want. Okay, yep, that's good. All right, so this one, notice what this is. Now we're getting to our graph. And notice what we've got. We've got our V shape, right? But it is not where it normally would be. Normally we would see it right here, and it would have a slope of, if you go back to your parent function, it would have or your toolkit function, it would look like this, and it would have a slope of 1 on this side, it would have a slope of -1 on this side, and it would look like this. Okay, does that make sense? All right, so the first thing I would say is figure out where the vertex, which is this like V point, has moved. And so we can see it's down here now. So where has it moved? It has moved to the right 3 and down 2. Does that make sense? So I'm just going to write that. It's moved to the right 3 and down 2. So if we're writing this out, we know the toolkit function is this. F of x equals absolute value of x, right? Just because of its shape. That's the toolkit function. So if we want to rewrite it, let's just change it to g of x. We know this absolute value still has to be there to give it the V shape. But how do we make these two things happen? Let's start with this one. How do we make it move to the right 3 spaces?
Outside.
Negative. Do you use negative in here, on here?
Probably.
Negative, so negative.
-3.
-3.
And where does it go?
Outside the x.
It goes inside with the x. Because remember, anytime you go left and right, that's x's. So it is going to, and it moves opposite. So that's why, since we moved it to the right, we're going to subtract 3. Okay? And then how do we make it move down? 2.
-2.
-2, and where's that? On the
Okay.
outside. So this makes it move to the right 3, and then this makes it move down 2. Okay? Now the other thing to look at here is, are these the same exact shape?
No.
No. Because if we just move this to the right 3 and down 2, you see that this one, the red one, is much wider than the bluish one here?
Mhm.
Okay? So they've changed something else. They've stretched it or shrunk it, right?
Mhm.
So with absolute values, it's actually pretty easy. Here's what we're going to do. We're going to look at, we knew the slope right here was 1, and the slope over here is -1, right? That's just what the toolkit function looks like. Notice the slope on this one. To go from here to here, what is the slope of that?
Up 2/1.
Yeah, up 2/1. So that slope is 2 instead of a 1. It used to be a 1, but it got changed, and now it's a 2. What's the slope on this side if we go from here to here?
From where to where? Sorry.
From the vertex up to this point.
Up to -1.
Yeah, and so that makes it a -2. So notice the comparison. The slope used to be a 1 on the right. Now it's a 2. The slope used to be a -1 on the left. Now it's a -2. So the nice thing about absolute values, because they're straight lines, all we have to do is take this slope over here on the right and put it in right here. So what they've done is, instead of going up 1 and over 1, you're going up 2 and over 1. It's a vertical stretch by a factor of 2. Okay? Does that make sense? Because the other one would have looked like that. So it would have only gone up 1 and over 1, but this one is going up 2 and over 1. Does that make sense? Instead of it going up 1, it went up 2, so it's been stretched. It's been multiplied by 2. If you went here, this one would go up 4 and over 2. This one would go up. That's going to be messy. I'm going to go this way. It would have gone up 2 and over 2. So again, instead of going up 2, it went up 4, twice as much as it would have. Okay, and so that's why the 2 goes here. But again, the easy way is just look at your slope, and the slope goes in the front here. Okay, that looks really messy by the time I'm drawn on it, doesn't it?
So the way you found the slope there at the beginning,
Mhm.
you went over 3.
We're
X,
talking,
and
which are we talking about?
the first part, like,
The first part of where this
Right
got
there.
moved over here?
yeah,
Okay,
you went,
so that's not slope, that's just where it got moved.
okay,
So it got moved 3 to the
3,
right
okay, and then
and down 2.
can you not do down to the
Sure.
right? You can do that?
Yeah.
Okay.
Because that's not really slope, that's just figuring out where it got moved.
Oh,
Okay? And then the left and right is always in with the x, and the up and down is always out here by itself. The slope is actually between 2 points on the line. Okay? Any other questions on that? We did some transformation stuff in the last chapter, right? So we've seen that before, or it was earlier in this chapter, one or the other. I'm getting my chapters mixed up because we had them all mixed up. So, but we have seen that before.
you're recording this,
I
right?
think it was on the test, wasn't it?
You're recording this?
I wasn't going to post it unless somebody really wants me to,
Thank you,
but
Jen.
because we got to get your question answered.
Mhm.
Okay. Yeah, so let's go ahead and go on. Although, again, it doesn't show up very well, so. Okay, so we got our answer there. Absolute 2 times absolute value of x minus 3, and then minus 2. All right, let's see if we can do this with words.
Mm.
So this one says, given the description of the transformed absolute value function, so that tells us right away we know it is f of x equals absolute value of x. Write the equation. The absolute value function is horizontally shifted left 2 units. I'm going to underline that in red. So left 2 units. I'm going to abbreviate. There you go. Then it is vertically flipped. What do we really call a vertical flip? What do we call it when we flip something? Anybody remember the more mathematical word other than flipped? Reflection. I don't know who said it, but you're right. Whoever said it is correct. It's a reflection, and it's reflecting vertically, so it's reflecting this way, right? So it's actually a reflection over the x-axis. Okay, and then what else? Green. And then vertically shifted up 3 units. So we know it's going to go up 3. Okay, so we've got 3 things to deal with here, kind of just like last time.
Is it left 52, not 3?
Yes, it is. Thank you. Because I would have gotten it all wrong there, because this is a 2, not a 3. All right. So now that we've got our numbers fixed, our equation, again, I'm just going to change it to g of x. It wouldn't be a big deal if you left it as f of x, but because we're just supposed to name it. We know it's going to be absolute value because they told us, right? How do we make it move to the left 2 spaces?
Left 2.
Plus 2, and is correct, but where does it go?
Inside.
Inside, because remember, left and right always goes inside with the x, because that's where x's go, is left and right. So plus 2 is correct, and it works backwards of what you'd expect. Then, how do we make it reflect over the x-axis?
Negative.
Yeah, put a negative. And we put a negative right here in the front. Now, if you think about what happens to that V shape when you reflect it, it used to be going this way, right? When you reflect it, now it's going this way, down. Okay? And then lastly, how do we make it go up 3?
Plus 3.
Plus 3 at the end. Outside all by itself. That's how you make it go up 3. Okay? So, who knows? Maybe it's easier with words. I don't know.
No.
Not really? Too many words are scary?
Mm-hmm.
Yeah. Any questions on that one? And in fact, what I'll do is I'll post both videos probably, I guess. But I won't. Yeah, it may be tomorrow before. I mean, it will be tomorrow before I get to it. Okay, so there's our equation. And you may or may not be able to see that from way back where you are, but. All right. So now we get to some of our rules for equations that deal with absolute values. So again, and I mentioned this earlier, when you think of absolute value, you're really thinking of distance from 0. So when we talked about that absolute value of 21, the reason that the absolute value of 21 is, besides just mathematically, this is what we do, it's because the distance from 0 to 21 is 21 units. And the same reason, the reason that negative 21 has an absolute value of 21 is because the distance from 0 to negative 21 is 21 units to the left. So it doesn't matter what direction, we're just working on distance. So it doesn't matter 21 units to the right or 21 units to the left, they both have an absolute value of 21. Okay? Now, we usually know, and I have seen some of you in class, and some of you I've never seen. I mean, high school class. That's what I mean. You've all been in this class. Good. All right. But so some of you may be coming from a different background. So are we okay with, do we understand what absolute value is? I mean, like if I ask you to do the absolute value of 12, do we all know that answer or not? Do we have questions on that? Okay. It's just 12, right? Absolute value of negative 7 would be 7. I mean, the shortcut is we just take off the sign. And that's the answer for absolute value. So, but when we deal with equations and we're kind of working backwards, we have to be a little bit careful. So here's our rules for dealing with absolute value. And I'm going to go ahead and put up the next piece because this is the words that I'm going to say. And here's what this symbol means in words. The absolute value of x equals c is equivalent to. So that's what those double arrows mean. That's a symbol that means is equivalent to. It means it's the same. They're either both true or they're both false. It's equivalent to saying x equals plus or minus c, as long as c is greater than or equal to 0. So here's why that's true. And I think I already maybe drew it before. But so the idea is, since absolute value is talking about distance from 0. We always start with 0 on our picture. And I'm going to draw a picture of a number line just to show you this. And if the distance from 0 is c, remember we said it doesn't matter if you go to the right or to the left. So if I go to the right, c units, this point over here would be c. If I go to the left, c units, this point over here would be negative c. Does that make sense? We could go either way. And what we're saying is x has to be either over here at c or over here at negative c if its absolute value is equal to c. And that's where this statement comes from. So we would say either x equals negative c or x equals positive c. Whatever, again, c is going to be a number. But right now we just don't have a specific number to put in there. Okay? So, and then this plus or minus sign just means both of these. It could be either one of these, plus or minus. Okay? So that's our rule, and we're going to use that when we start solving equations. And hopefully I'm going to draw those pictures for you, and hopefully that will help us visualize what's going on. Okay? So here's our first equation. And it's not actually set up as an equation yet, but here's what it asks us. Find the horizontal intercepts, or the x-intercepts, of the graph of f of x equals, and then you have this absolute value of f of x plus 1, and then minus 7. Now, does anybody remember? And I think this was, again, we've covered this. I just don't remember if it was chapter 1 or chapter 2. How do we find horizontal intercepts?
Is it the y2 minus
It has something to do with 0. So do we all recognize the horizontal or the x-intercepts are going to be on that line where it crosses the x-axis? That's the intercepts. And every point on this line has something in common. So let's say, for instance, this is the point 3, 0, and this is the point 1, 0, and this is the point negative 2, 0. What do they all have in common? The 0 is the y value, right? Or the output value. So that's how we find these. If we want to find them, we take this output and we say the output has to be 0. Okay? And that's just a rule. I mean, you can draw it to C, but that's always going to happen. Anytime you're looking for an x-intercept, you just make sure the output value is a 0. Okay, so now we have an equation. Now we're going to try and solve this equation using what we learned on the last slide. So before you can solve an absolute value equation, the first thing you have to do is what we call isolate the absolute value. Get the absolute value part by itself. So what we have to get rid of is what? Yeah, this minus 7. And how do we get rid of that minus 7? We add 7. Very good. I need less markers here, so get rid of some of those. So add 7, and if we add 7 over here to cancel, we have to add 7 on this side as well. So now we're going to have, is the green, can you guys see the green in the back? And the red? Can you see both of these colors or no? Yes? Good? All right. So 7 equals the absolute value of 4x plus 1. And now our absolute value is isolated. It's by itself. Okay? Now here's where we're going to kind of think of that picture in our minds. Not this picture. We want to think of this picture. Because we know the absolute value of this thing, it doesn't matter what it is right now, but the absolute value of it is 7. Which means its distance from 0, whatever this is, its distance from 0 is 7 units. And it might be 7 units to the right, or it might be 7 units to the left. Does that make sense? And another way to think about it is, if I just said, I'm thinking of a number in my mind, and you guys are going to guess it, try to guess it. And I give you a clue. The absolute value of the number that I'm thinking of is 7. What would your two guesses be? 7 or negative 7, because those are the two numbers that have an absolute value of 7, right? So that's where we can go with this. We know that 4x plus 1 equals a negative 7, or 4x plus 1 equals a positive 7. Those are the only two numbers that could be in here that equal 7. So those are the only two numbers that 4x plus 1 could equal. Now here's a little hint, because a lot of times we sometimes forget about there's two answers or two parts to it. So here's my little hint. What I try and show you guys is, to help you remember this, is you've got two absolute value bars, right? You need one little equation for each of those absolute value bars. That's not anything mathematical. It's just to help us remember there's two parts to it. Okay? So then once we've got our two little equation, the absolute value bars are gone, and we just solve it like we have previous equations. So what are we going to do here on this first one?
Subtract 1.
Yeah, subtract 1 from both sides, and that will cancel. And we will have 4x equals, and negative 7 minus 1 is negative 8. And then what else will we do?
Divide by 4.
Divide by 4 so that this cancels. And we have to do the same thing on the other side. And we will get x equals negative 2. So that's going to be one of our answers. X equals negative 2. Then we're going to go over here, and we're actually going to end up doing the same steps, because the first thing we're going to do is subtract the 1, because it's 4x plus 1, 4x plus 1, right? They're the same. Now, we do have to be careful, because this time when we subtract the 1, we have 4x equals 6. 7 minus 1 is 6. Sometimes people will just automatically, oh, that one was negative 8, this one must be positive 8, and that's not true, usually. And then what else do we have to do?
Divide by 4.
Divide by 4 on both sides to cancel this one out. And we get x equals 6 over 4, but that reduces to be 3 over 2. And I don't know if you have noticed it yet, but the computer program likes fractions. They don't like you necessarily very often to change it to a decimal. Sometimes they'll say, this is not in fraction form, or whatever it says. But if you get it wrong because you type it in as a decimal and it's the same answer as the fraction, I will give you credit for that. I always check. I go back through, and I don't know if you've noticed, but I usually add some little points on if there's something that should have been right and the computer counted it wrong. It is looking for very specific things because that's how it's programmed. But these are our answers. Now, do you remember from past equations, how do you check your answers? You plug it back in. So if we wanted to check this, and it's not a bad idea, we would take this negative 2 and plug it in here, back in the original equation. And 4 times negative 2 is negative 8. Negative 8 plus 1 is negative 7. The absolute value of negative 7 is 7. And 7 minus 7 is 0, and that checks out. I just realized I made one mistake, and I'll fix it in a second. We could do the same thing with 3 halves. We plug it in. 4 times 3 halves is actually 6. 6 plus 1 is 7. Absolute value of 7 is 7, and 7 minus 7 is 0. So that one checks out as well. Here's my little mistake. And I did it on the video too. I did it again. So they asked us for the x-intercepts. X-intercepts are points on a graph. Does that make sense? They're the points that are on the line. So when we give our answer, I mean, we did everything right, but when we give our answer, we should say negative 2 comma 0, like we saw on the graph. And then this one would be 3 halves comma 0. And usually, again, the computer has a little hint, like write these as ordered pairs. And that's your hint that you should write it as that comma 0 stuff. Okay?
I got a question.
Yes.
So every time you do, absolutely, you have to do one positive and then the next.
It'll be 2 parts. Yep. Yeah, you'll always have those 2 parts. And that's why I say you see the 2 absolute value bars. That's a reminder. You got 2 parts. Yep. There's only one exception to that, and we're going to hit one like that. So you'll see that in just a minute. Okay, so there's our 2 answers. And again, I messed that up on my answers. Let's take a look at, before I go on, before I erase this, any questions on that you want to ask? Any other questions that you want to ask? All right. Okay, so this one, there's no x-intercepts or anything. It's just solve. So it's already set up. And what do we have to do first? Because it's already an equation. What do we want to do first? Subtract 2. And why? You're right, but why?
Because you
We need to isolate the absolute values first. And you're exactly right. First thing we're going to do is subtract 2 from both sides of our equation. Subtract it over there and it cancels. And that's going to leave us with -1 equals 4 times x minus 2. And remember that when you've got a 4 right next to the absolute value bars, just like parentheses, it means times. So I went ahead and put the times sign in there just to emphasize that. It means multiply. What else do we need to do? You need to divide by 4. Be careful, because absolute value bars are not parentheses. We can't distribute through. Okay, so you have to divide to get rid of the 4. And we know we should divide because they're multiplying. We want to divide. I switched my color scheme up. Okay. -1/4 equals absolute value of x minus 2. Okay. Now I'm going to stop us right here before we mindlessly go on. Does anybody see a problem with this? We did all our, just so you know, we did all our math right. Does anybody see a problem with the equation of what this says?
negative.
Perfect. Say that again so everybody can hear it. The absolute value can never be negative. So if we're saying the absolute value of x is equal to -1/4, that's a problem because that can never happen. So in this case, this is impossible. We would say this is there's no solution. And that was what I was saying is this is the case. If you ever get a negative, that you don't even have to worry about doing the 2 parts. It's just you stop. Now, that doesn't mean you couldn't, because again, sometimes we get in, I'm just going to always do this. And we would write x minus 2 equals -1/4. And we would write x minus 2 equals +1/4. And you could solve these. And you would get an answer. The problem is, when you go back and you plug it in, or I guess up here, it wouldn't make it a true statement. It wouldn't work. Okay, so that's why it is always a good idea to go back and check. But I'm not going to require it. But you know, in a case like this, if you're just plowing through, that is something that can happen. You can have times where there's no solution because absolute values, as he said, can never be negative. Never. Okay, does that make sense? Absolute values are always positive or equal to 0. So that one is no solution. Any questions on that? Is that concept okay? Okay. All right. So that's equations. And now we're going to talk about some inequalities. And we had, and so this is where we're going to come. We've got the less than, and we're going to do the greater than also. Okay? Because we do have 2 options. So here's what this first one says. It says the absolute value of x is less than c. And what the statement says is that is equivalent to, or it's saying the same thing as saying that x is between a -c and a +c. So again, I'm going to try and draw a picture to help us make sure we understand that. So here's our 0. And here's our, I'm going to make these a little taller. This is c units to the right. And then this is c units to the left. So -c. And it's not equal to this time. It's a less than statement, right? So we're going to think of these places over here and over here as not just points on the graph, but we're going to view them as fences or boundaries. Okay? So there's a boundary, c units to the right. There's a boundary, c units to the left. And what this statement right here says is, if we think back to the meaning, x's distance from 0 is less than c. Okay, its distance from 0 is less than c. Now, what does that mean on the graph? It means that if these are the boundaries, it's got to be closer to 0, right? It's like if you say, this is the other example that I usually use. So if I say that I let my kids go outside as long as they stay I'm going to make it just a number up. So as long as they say less than 20 feet from the house, what does that mean? It means there's this like imaginary fence 20 feet from my house, and it's okay if the kids go outside as long as they stay inside that fence, right? That makes sense? So a distance less than means that you're closer to 0. Your x could be here, or your x could be here. You just can't have the x jumping out of the fence and going further away. Okay? So what this is saying, x has to be in between this boundary, negative c, and this boundary, positive c. And since the negative c is the less than one, it's always less than when we draw these. So x is between those two because it has to stay inside the boundaries, inside the fences. Okay? So it's going to stay in between them. And you can memorize this, that's fine. I try and draw it so that we can kind of visualize close to 0 that way. But either way, just one way or another, we need to remember that. Now the next one, the only difference is what? The or equal to sign. Notice nothing else changes. So it's really the same picture. Okay? The difference as far as the picture is now they could be sitting on top of the fence. And that's okay. Okay, if you remember the equal to, they were on that boundary. Now we're saying they're less than or equal to. So the only difference is when you write it, it's going to be an or equal to sign instead of just a less than sign. It's the only difference between those two. All right, the third one. Now we have to change our picture. So we've got 0, we've got our c boundary and our negative c boundary. And again, those are just numbers. Now, here's what this one says. Our distance from 0 is more than c, or greater than c. And again, that would be like if I said to you, my house is more than 5 miles from this building. Now, what does that mean? Well, it's like there's this imaginary boundary at 5 miles, right? And my house has to be on the outside of that. It could be that way, it could be that way, it could be wherever, but it's further away than that boundary of 5 miles. Does that make sense? So what that looks like in the picture is x is outside of the boundary over here, or it's outside of the boundary over here. Right? It's further away in one direction or another. Fortunately, on number lines, we can only go left and right. We don't have 3 dimensions. Okay, but it's further to the left, or it's further to the right. Now, when we draw that with our equation or our inequality, this would say x is less than the negative c, because x is to the left of the negative c. Or, if we draw this one, it's x is greater than positive c. Because it's got to be further away. So it's either further to the right, on the right side, or it's further to the left, on the left side. Does that picture make sense? And again, you can memorize. I have some students who they just love to memorize this, and they just memorize it, and that way they don't have to think about anything. But I want you to be able to see the picture and have both options if you want to. Okay, and then again, the other one is if there's an or equal to sign on it, doesn't change the picture at all. It just means now we have the or equal to sign on it. We include the boundary. Okay, and so what that is going to allow us to do is now move on and solve some inequalities. So are there any questions on this concept before we go on to the next one and actually use it? All right. Oh yeah. And again, think distance from 0, less than or equal to means it's closer to 0. It's in the middle, right? Greater than or equal to means it's farther from 0. So it's going to be the 2 sections on the outsides. That's the 2 options for inequalities with absolute value. You're either dealing with the middle or you're dealing with the 2 outsides. Less than is the middle, greater than is the 2 outsides. All right, so let's do an example of how we would solve this one. Again, our first step is to isolate, but what do we see here? It's already by itself, the absolute value. Okay, so if we want to draw our picture, where are the boundaries this time? If we're thinking about that boundary idea, 4 to the right and 4 to the left. Correct. So here are the boundaries at 4 and at -4. And where does this, now it's not just an x, but where does the x minus 5 have to be if its distance from 0 is greater than 4? It has to be outside of the boundaries, right? So that means the x minus 5 could be over here, further to the left, or could be over here, further to the right. That's what happens anytime it's a greater than. It's the two outsides. Now, what does that tell us? It tells us x minus 5 is less than or equal to the -4, because it's an or equal to problem, or the x minus 5 is greater than or equal to the +4. Now I'm going to pause before we actually solve that. Do we have any questions on why those are the signs, or why it's like that?
So what's the reason the science book?
Okay, and if you look at the picture, the reason is because in this case the x minus 5 is to the left of the -4, and on a number line, anytime you're to the left of, it's less than. So this is less than this, and we could write it this way, but usually write the x minus 5 first. But we could say 4 is less than this, right? But usually we like to say it better that x minus 5 is greater than the 4. So, I mean, you could write this this way also, but it really says the same thing. Does that make sense? It's like one of those things like saying I'm older than you, or saying you're younger than me. It really says the same thing, but just in a different order, right? So that's why. Does that make sense?
Yeah.
Okay. Any other questions before we actually go ahead and solve it? All right. So, and again, notice once you set up your inequalities, the absolute value bars are gone. We've taken care of that with our picture and setting up our two inequalities, our two parts. What do we have to do on this one? It's a really short one.
Add 5.
Add 5. And we get, this cancels, and we get x is less than or equal to 1. Or, then we go to the other one, and notice we're going to do the same thing, right? Add 5, and that cancels. So we get x is greater than or equal to 9. Okay? Now, the other thing this program really likes to do is ask for interval notation, right? You give your answer in interval notation. So you might just be able to look at this and know the answer of how you would write an interval notation, but I'm going to draw a picture quickly just to show you. We've got a boundary here at 1 and a boundary at 9 from these two. You remember how the dots work? If it's a less than or equal to, what kind of dot goes on this one? A closed circle. That means that it's an or equal to, so it's a closed circle, and it's less than, so it's going this way. And then the same thing here, it's or equal to, so it's going to be a filled in circle here, and it's going to the right. And maybe it's easier to draw this now, but I like to see the picture. So I've got two separate intervals, right? How do we describe this one?
1 to negative infinity to 1.
Yeah, negative infinity, because it goes forever this way, right? So there is no endpoint on the left-hand side. It's just negative infinity. But on the right-hand side, it stops at 1. What do we know always goes with the infinities? Parentheses, good. In this case, what's going to go with the 1? A bracket. Why? It's a closed circle or the or equal to, either one. So we've got that. And then when we do this side, how would that one look?
9 to infinity.
9 to infinity. And I heard somebody say closed circle, so that means bracket, right? And then the infinities always get parentheses. And then what goes in between here? U. Now, if you're looking for that U, it's not just a capital U. If you're looking for that on your computer, if you notice there's this like symbol box, you just have to go over a couple of times, and then you'll see the U is actually a symbol that they can allow you to put in. So I don't know if you've seen, hopefully you've seen that by now, but if not, that's where you're looking. So that's our answer for that one. And again, we did interval notation because usually the questions that you're doing for homework ask for interval notation. Any questions on that before we go on? think that was the end, but I could be wrong.
It is.
It is. That's the end. Okay. So there are 6 questions like that. And again, I will mention, don't be afraid to do the practice sections, because those questions will be kind of similar. Or even if you get stuck on one, to go back and look through the practice and find one that's kind of similar to it. And that's going to help you out a little bit.